Okay, student, based upon these equations and concept we learned, we are going to solve problems. Question number 3. Already we have solved 2 problems. A stick graph of a particle is shown in the diagram. Start from origin, goes like this. Different regions I am going to select. Region A, region B, region C, region D, region E. What are the region or identify the region in which velocity is positive, velocity is 0, velocity is negative. The question is identify the region in which velocity is positive, velocity is negative and velocity is 0. Look at the point A. Slope of a stick graph gives velocity. If you draw a tangent at A, that tangent makes an angle theta which is less than 90 degree. So, velocity at A is equal to positive. If you draw a slope at B, that tangent will be parallel to time axis. So, velocity at B is equal to 0. If you draw a tangent at C, that straight line makes an angle greater than 90 degree. Therefore, velocity of C is negative. Likewise, at D, slope makes an angle 0 with x axis. Velocity at D is equal to 0. The slope at E is positive. Therefore, velocity is positive. So, from this graph we have identified a positive, negative and 0 velocity region. Okay, student, we pass on to the next VT graph. Question number 4. This is the VT graph given to you. Is passed through origin. Meter per second is the unit of velocity. Velocity mentioned on y axis is 8 meter per second. This is 2 second, 4 second. From the graph, find acceleration, find displacement after 4 seconds. At the end of 4 seconds, draw a stick graph. These are the questions. For this VT graph, we have to draw a stick graph. Shall we go to the problem now? Okay. What is acceleration? VT graph slope gives acceleration. Slope of VT graph. Look at the VT graph. Let it makes an angle theta. This height, that is 8 unit. This base 4 unit. Therefore, tan theta, slope of VT graph is acceleration. Acceleration is equal to tan theta is equal to opposite side by adjacent side, that is equal to 2 meter per second square is one way. Or slope is equal to, I take this point as origin as point A. This is A point, coordinate 0, 0. This is B point, coordinate 8 comma, sorry, 4 comma 8. X1 comma y1 is equal to 0 comma 0, x2 comma y2 is equal to 4 comma 8. Therefore, slope is equal to y2 minus y1 by x2 minus x1. That slope is called acceleration here, VT graph. y2 8 minus 0 by x2 4 minus x1 0. A is equal to 2 meter per second square. Another way to calculate slope. So we have calculated acceleration. Now they are asking what is the displacement. Okay, what is the general equation for this velocity as a function of time? It is in the form of y is equal to mx plus c, where c is constant, 0, because the graph is passing through origin. Y, we mentioned velocity, slope, that is acceleration, 2x plus 0. So velocity is equal to 2x. On the x axis we mentioned the time, t. V is equal to 2t. This is the velocity as a function of time. Initial velocity u is 0. So velocity can be written as ds by dt vector. That's equal to 2t. ds vector is equal to 2t dot dt. Integral ds vector is equal to 2 integral t dot dt. 0 to s. That is s vector, that's equal to 2 into t square by 2. So s vector is equal to t square. This is the displacement vector. So what is the graph of this displacement time? It is a parabola. It shows like this. We have learned how the ST graph will be. Okay. This is a question. Draw the ST graph C. Okay. We displacement at the end of 4th second asked. So displacement at the end of 4th second. Yes, at the end of 4th second is equal to 4 square, that's equal to 16 meter. So we got the answer for the second question. Also we drew the graph of ST third question. Student, now we are going to learn one of the important point regarding area under VT graph, what it represents. So the graph is given like this. It means VT graph is straight line. The slope of the VT graph is acceleration, that is given A. Let us calculate in the given interval t1 to t2 or 0 to t the area under the graph. Okay. In this graph, let us select a small unit in the interval delta t second. What is the area below the graph with the x-axis? It is almost like rectangle. So area of the element is equal to, this height is v, height into width delta t. This velocity is the function of time. What is the velocity as a function of time? We can get v is equal to, it is in the form of y is equal to mx plus c in y we have taken v, slope is given as a, at plus c is u. V is equal to u plus at. Okay. Therefore, area under the graph is equal to u plus at dot dt. This is not delta t, dt. So, let us integrate. Integral dA is equal to integral u dot dt plus integral a dot dt. So, area in the interval 0 to t second we are calculating. Therefore, u into integral dt is t, 0 to t plus a into integral t dot dt, t square by 2. Therefore, sorry, this is t, ut plus half at square. This is an equation of displacement. Therefore, area under ST graph gives, sorry, this is VT graph, gives displacement. Very important concept. Dear student, likewise, if you calculate area under VT graph, that gives, sorry, area under AT graph, acceleration may be constant or variable, may be a function of time. Suppose I take an acceleration as a function of time. This is the initial acceleration. This is a naught, we take it. In the interval 0 to t, if you calculate, you will get a change of velocity. So, area under AT graph gives change of velocity. Let us see that. Let us take an element, elemental area. This is area dt, then area of the element is equal to A into dt. Area is equal to A naught plus mx. M is the slope. What is meant by rate of change of AT graph? That is called jerk. Rate of change of velocity is called acceleration. Rate of change of acceleration is called jerk. We need not to discuss about jerk. Let us stop up to rate of change of velocity only. That too we are discussing constant acceleration. Okay, we need not to bother about the next physical quantity called jerk, rate of change of acceleration. That I have taken as mx only. Okay. Then integral dA is equal to A naught plus mt. This is mx. On x axis we have mentioned t. So, mt dot dt. This area is equal to A naught integral dt plus m into integral t dot dt that's equal to a into t 0 to t second plus m into t square by 2. This is nothing but change of velocity. At, acceleration into time. V is equal to u plus at. In dimensional analysis we can learn product of a and t gives velocity. This is a change of velocity. At t is equal to 0, the velocity is u. At t is equal to t, the velocity is v. If so, v minus u is equal to at plus half m t square. Okay, student, well, let us go to fifth problem. Displacement of a particle as a function of time is given 3t plus 2 in meter. Find its velocity at t is equal to 2 seconds. This is the problem. Okay, we know rate of change of displacement is called velocity. ds by dt is equal to 3 into dt by dt plus differentiation of constant 0, that's equal to 3 into 1, that's equal to 3 meter per second. It is independent of time, so it is constant. Always at t is equal to 0, at t is equal to 2 seconds, velocity is constant. Problem, let us pass on to the sixth problem. Displacement of a particle is given as 3t square plus 2 meter. Find its velocity at the end of 2 seconds. This is a question. So, displacement as a function of time is given 3t square plus 2. Okay, student, let us differentiate displacement with respect to time to get velocity. ds by dt, that's equal to d by ds of, d by dt of 3t square plus differentiation of constant 0, 3 into 2t, then v is equal to 6t. The velocity as a function of time, we got it. But what they asked, velocity at t is equal to 2 seconds asked. Am I right? That is equal to 6 into 2, that's equal to 12 meter per second. Student, shall we draw a graph of VT graph for the above? It is in the form of y is equal to mx plus c, that is c is equal to 0. So, VT graph is a straight line pass through origin. Then what about the slope? Y is equal to mx plus c format. V is equal to 60 plus 0. Slope m is equal to 6. Therefore, acceleration a is equal to 6 meter per second square, we get it. Okay. Okay, student, we pass on to the next problem, seventh problem. Here velocity time graph is given to you. Velocity is in meter per second, time is in second. 8 meter per second is attained after 4 seconds. This is the VT graph. From the VT graph, find displacement of at the end of 6 seconds. This is the problem. Student, velocity is not constant. Velocity as a function of time. You can get an equation for velocity as a function of time. Let us calculate a slope. What is the slope of this graph? Slope is equal to acceleration. That is 0. This point I take origin and this point B. A and B, slope is equal to 8 minus 0 divided by 4 minus 0, that is equal to 2 meter per second square. Initial velocity is equal to 0, therefore V is equal to U plus AT form. You can get it, that is 0 plus 2t. V is equal to 2t. This is the velocity time. But we have to calculate a displacement, and from S is equal to ut plus half at square formula. Initial velocity 0, half acceleration we found 2 into t square. Displacement at the end of 6 seconds they are asking. At t is equal to 6 seconds is equal to these 2 get cancelled. Therefore 6 square. 36 meter. Got it. This is one of the method. This is method 1. You can take it. Method 2. Student, I already explained area under VT graph. Gives displacement. Look at this VT graph. After 4 seconds, velocity is 8 meter per second. Area of this triangle we have to calculate. This area enclosed by the graph with the x-axis. That's equal to half into base into height. That is a displacement. So half base 4 minus 0, height 8 minus 0, that's equal to half into 4 into 8, that's equal to 2 into 8, that's equal to 16 meter. This is another method. Area under VT graph gives displacement. Problem number 8. Student, from the VT graph, let us calculate a displacement velocity after or at the end of 10 seconds. Let us draw a stick graph. Let us calculate a displacement let us calculate a maximum displacement. Okay, shall we go to the problem? Look at the VT graph. This graph, that straight line makes an angle more than 90 degree with the x-axis. Slope is negative. I take, first of all, I calculate the acceleration. I draw the graph once again. I want to find acceleration. This point is A, coordinate is 0, 8. This point is B, coordinate is 8, 0. x1, y1 is equal to 0, 8. x2, y2 is equal to 8, 0. Therefore, slope is acceleration y2 minus y1 by x2 minus x1 is equal to y2 is 0 minus y1 is 8 by x2 is 8 minus 0. A is equal to minus 1 meter per second square. We got acceleration. Initial velocity we call, this is the initial velocity. Initial velocity is equal to 8 meter per second. So what is asked? Velocity at the end of 10 seconds is asked. From v is equal to u plus at, we can get velocity as a function of time. V is equal to 8 minus t. Velocity at the end of 10 seconds. Therefore, velocity at 10 seconds is equal to 8 minus 10, that is equal to minus 2 meter per second. There is another method to calculate this velocity. Shall we go to the method 2? This is the graph, VT graph. This is 8, this also 8, this 10 second. We have to calculate this velocity, this height, I take it as V. Now, the angle made by this graph with the x-axis, this angle I take theta, therefore this angle also theta. So, what is OA is equal to 8. This point we can take as B, sorry, not A. This point is B, this point is A. OA is 8, tan theta is equal to OA by OB, that is equal to 8 by 8, that is equal to 1. Similarly, in the next triangle, tan theta is equal to V divided by BC. What is BC? BC is equal to 2 seconds, 10 minus 8, 2, that is equal to 1. Therefore, B is equal to 2. Magnitude of velocity is 2 as it is in the negative y axis. This is minus V. So, minus V is equal to minus 2 meter per second. Velocity is negative. Alright. Tan theta is equal to, here itself we can put minus, then you won't get any confusion. Okay. This is another method. What is the next problem? Draw a ST graph. Okay, let us get the equation of displacement. S is equal to ut plus half at square. So, S is equal to u, initial velocity 8t minus half into 1 into t square, 8t minus t square by 2. It is an equation of parabola. Student, S t at t is equal to 0, S is equal to 0, it starts from the origin. Okay. At what time the displacement becomes 0? One more. Shall we calculate? At t is equal to 0, S is equal to 0 and 80 minus t square by 2 is equal to 0, 80 is equal to t square by 2, then t is equal to 16 seconds. At t is equal to 16 seconds, again s is equal to 0. I take this is a 16 second. Meanwhile, it is a parabola going like this. It can be extended like this also. Okay. At some time, say 8 second, velocity displacement is maximum. We are going to calculate what is the maximum displacement. Next question. Am I right? Yeah. ST graph we plotted maximum displacement. I said at 8 second displacement is maximum because the slope is 0 at maximum. We go to equation. S is equal to 80 minus t square by 2. Rate of change of displacement at maximum is 0. Therefore, ds by dt is equal to 8 minus 1 by 2 into 2t is equal to 0. 8 minus t is equal to 0. T is equal to 8 second. At 8 second displacement, at t is equal to 8 second, rate of change is 0, it is maximum. S is maximum. Therefore, S maximum is equal to 8t minus t square, 8 square by 2. That is equal to 64 minus 64 by 2, 32. So, 32 meter. Maximum displacement of this particle is 32 meter. Question number 9. Displacement of a particle given as 5t plus 5t square. Find velocity as a function of time. Student, there are two different methods. S is equal to ut plus half at square format. It is in the form of S is equal to ut plus half at square. At the place of u, what is there? 5 meter per second. At the place of half at, half a, 5 is there. Therefore, a is equal to 10 meter per second square. Therefore, we can write v is equal to u plus at. It is constant, a is constant. Therefore, you can use the formula v is equal to u plus at. V is equal to u 5 plus 10t. We calculated velocity as a function of time. This is method 1. Shall we go to the method 2? S as a function of time is given. Rate of change of displacement is called velocity. 5 into dt by dt plus 5 into d by dt of t square. That is equal to 5 plus 5 into 2t. That is equal to 5 plus 10t. This is another method. Velocity as a function of time. Student, we go to the next problem. Velocity is equal to 16 plus 10x whole power of. Find the displacement as a function of time. The above equation is in the form of v square is equal to u square plus 2as. Square on both sides. V square is equal to 16 plus 10x. It is in the form of V square is equal to u square plus 2as. Therefore, u square is equal to 16, u is equal to 4 meter per second, and 2a, yes, here given as x displacement, 2a is equal to 10. So, a is equal to 5 meter per second square. Therefore, acceleration is constant. We can use this form ut plus half at square. S is equal to 40 plus half into 5 into t square. S is equal to 40 plus 5 by 2 t square. This is the displacement as a function of time. Okay, student, let us pass on to the 11th problem. Displacement as a function of time is given as 2t plus t square. Here we are going to find average velocity. In the interval of time. T is equal to 0 to 2 seconds. Student, we know what is meant by average. Integral v as the function of time dot dt divided by integral dt. Here displacement is given. Shall we calculate a displacement? From the displacement, shall we calculate velocity? So, dx by dt is equal to 2 into dt by dt plus d by dt of t square. So, velocity is equal to 2 plus 2t. Okay. This is the velocity as the function of time. Therefore, average velocity is equal to integral 2 plus 2t dot dt 0 to 2 whole divided by integral dt 0 to 2. So, average velocity is equal to integral 2 into dt 0 to 2 plus integral 2t dot dt 0 to 2 whole divided by integral dt is t 0 to 2. That is equal to 2t 0 to 2 plus 2 t square by 2 0 to 2 by 2 minus 0. That is equal to 2 into 2 minus 0 plus 2 into 2 square by 2 minus 0 whole divided by 2. That is equal to 4 plus 4 divided by 2. 8 by 2, that is equal to 4 meter per second is the average velocity. Student, shall we learn another method? We go to the method 2. Displacement is given as 2t plus t square. Am I right? Shall we calculate what is the displacement after 2 seconds? At the end of 2 seconds, what is the displacement? 2 into 2 plus 2 square, that is equal to 4 plus 4, that is equal to 8 meter. What is the total time taken? 0 to 2 seconds, 2 minus 0, that is equal to 2 seconds. Therefore, average velocity is equal to total displacement by total time taken. That is equal to 8 by 2, that is equal to 4 meter per second. This is another method. Student, we go to the 12th problem. A particle is accelerating uniformly from rest for some time and then decelerate and come to rest finally. If total time lapse is t second, what is the maximum velocity attained? What is the displacement of the particle? This is the question. I tell you about this problem in a graph. If you plot a graph, VT graph, the particle is accelerating uniformly from rest, initial velocity 0, to certain maximum velocity it reaches. I say Vm is the maximum velocity. Here acceleration alpha, it is positive, slope is positive, time taken is t1 second, let us take it. And then it come to rest with the uniform deceleration beta, time taken is t2, total time lapse is t second. What is asked? Maximum velocity attained, total displacement in the time lapse t second. This is the question. Okay, shall we go to the problem? Solution. In the VT graph, area under VT graph gives a displacement. Let us take from 0 to t1 second. Zero to t1 second. Here t1 second. This is the height is Vm. Area under this graph. Slope of this graph. Acceleration. Slope is equal to alpha is equal to Vm minus 0 by t1. Alpha is equal to Vm by t1. Let us take another slope. From here, maximum velocity in t2 second it reaches the 0 velocity. Here slope is negative, deceleration is beta, slope of that second graph beta is equal to minus Vm by t1, from which you can calculate t1, sorry, this is t2. T1 is equal to Vm by alpha. Here if you calculate t2, time cannot be negative, you have to take the magnitude of Vm beta. Total time lapse t is given, but t1 and t2 are not given. Therefore, t1 is equal to Vm by alpha plus Vm by beta. So, t is equal to Vm into 1 by alpha plus 1 by beta, that is alpha plus beta by alpha beta. So, the maximum velocity attained is equal to alpha beta into t by alpha plus beta. This is a problem asked once upon a time in IIT main examination. At the time it was a screening test, not main test. Okay, student. Area under this VT graph gives displacement. Okay. Area under VT graph. S is equal to half into base into height. Half. Base is equal to time, total time lapsed. Height Vm. Vm just now we calculated. That is alpha beta into t by alpha plus beta. Therefore, S is equal to half alpha beta t square by alpha plus beta. This is the total displacement of the particle in the time lapse t second. Okay, student, we pass on to the next problem, 13th problem. A train is moving with a constant acceleration. This is the train. Its engine crossing a pole. This is the pole. While crossing the pole, its velocity is u. When the last compartment crosses the pole, the velocity is v. What the question is, what is its velocity when the middle compartment crosses the pole? The question is, what is the velocity of this train when the middle compartment crosses the same pole? V dash I take, V dash is equal to what? This is the question. Okay, I want to take this length of the train as S. When the last compartment crosses the pole, the displacement of the train is S. When the middle compartment crosses the pole, the displacement is S by 2. Now you can understand. The problem is very easy. The first case, we take a engine and last compartment. Let us write down the equation. V square is equal to u square plus 2as. Now, engine and middle compartment, initial velocity v dash square is equal to u square plus 2a, displacement s by 2. So, v dash square is equal to u square plus as. So, as you can get from this equation 1. V dash square is equal to u square plus, from equation 1, 2as is equal to v square minus u square. Therefore, as equal to v square minus u square by 2. So, v dash square is equal to u square plus v square by 2 minus u square by 2. That is equal to v dash square is equal to u square by 2 plus v square by 2. Therefore, v dash is equal to square root of u square plus v square by 2. This question also asked in one of the competitive examination.